Hello, this is Peace Daddy. Today's lesson is going to be on multiples. This is the second part in a series of lessons about multiples. And today we are going to focus on the research of common multiples. That will be our focus for today, the research of common multiples. So after you've done the first lesson and you are really comfortable with skip counting and working through the bead cabinet, we're going to do some paperwork, and you're going to have lots of forms to fill out. And what that's going to help you do, these forms are going to help you figure out or deepen your understanding of what a multiple is and what multiples mean. So far, you should have found out that multiples of one number can also be multiples of another number. And I want to demonstrate this by looking at the bead bars. And let's take a look at the 2 and the 3, the 2 bar, the 3 bar, and a 4 bar. So we can construct multiples of 2, 3, and 4 with the bead bars, and you can note that these different numbers, 2, 3, and 4, have like multiples. So let me show you what I mean by that. So the first multiple of 2 is 4, and then the next multiple of 2 is 6. And if I'm working with 3, the first multiple of 3 is 6. So 2 and 3 both share a common multiple. They both have a multiple called 6. And 8 is a multiple of both 2 and 4. So if I'm just looking at 2 and 4, I can see that the first multiple of 2 is 4, the first multiple of 2 is 2, the second multiple of 2 is 4, and the first multiple of 4 is 4, so they have a common multiple there. But also, the second multiple of 4 is 8, and the fourth multiple of 2 is 8. So 2, 4, 6, 8, and 4 and 8. We can look at it this way as well. 2, 4, 6, 8, and then 4 and 8. So they also have a common multiple. So 6 is a multiple of 2 and 3, and 8 is a multiple of 2 and 4, and 12 is a multiple of 2, 3, and 4. Let's look at that. So 2, 4, 6, 8, 10, 12, right? 1, 2, 3, 4, 5, 6 twos is 12, and 3, 6, 9, 12. So you can use 3s to make 12. 1, 2, 3, 4 3s makes 12. And with the 4 bar, 1 4 is 4, 2 4s is 8, and 3 4s is 12. So 12 is a multiple of 2. 12 is also a multiple of 3. And 4 has a multiple called 12. So you'll discover by doing work like this, and you should practice this, that some multiples match more than one number. And when you worked with all of the bead bars on multiples, you can start working with what is called table A. And if you're in my class, table A is in our Google Classroom in the Drive section, and you'll immediately notice that when you look at this, the smaller the factor, the longer the column will be. So this is the column for 2's, and it says 2 times 1, and then 2 times 2, and then 2 times 3, and so on and so forth. So this is called table A, and this is what you're going to need to do first. And you can complete table A by using the bead bars. And if you don't have the bead bars at home, because you're working from home virtually, then you can use virtualmontessorimaterials.com. And I'd like for you to fill out table A. It goes from 2 to 3 to 4, all the way up to 10. And then it keeps going. There's another table called table B. And these are the 2's over here, and then the 3's, and so on and so forth. And I'd like for you to complete both of those tables, A and B. And then when you're done with that, again, you can look on Google Classroom, and you can go to the third chart on the drive there, and this is called table C. Now, table C doesn't have all of the factors, so it doesn't say one number times another number, what's the answer? It just has the numbers, and then a big blank. Okay, so you have the numbers 1 through 100. There's a first part to table C, and there's a second part to table C. And the last number on there is 100, and you're gonna fill out the whole chart. So, how do you fill out that chart? Well, what you do is you start thinking about all of the ways that you can make that number. So for 1, if I'm filling out chart C, I think about, how could I make 1? Well, I've been practicing, and I know that 1 times 1 makes 1. And that's the only way I can make 1. And then you go to the next number. What about 2? How can I make 2? Well, 1 times 2 equals 2. And then I can find the opposite of that. The commutative property tells me that 2 times 1 equals 2. So I put that there. 3, same thing. 1 times 3 equals 3, and 3 times 1 equals 3. Now, when you get down to 4, and a lot of the other numbers, you'll start to notice something different. On 4, 1 times 4 is 4, but also 2 times 2 is 4. And then the last one that you'll put is the opposite of the first one, which is 4 times 1. Right? So don't forget about the commutative property. You don't have to put 2 times 2 twice, because 2 times 2, the 2 comes first in each case, and the 2 comes last in each case. So you don't need to do that. So you fill out the entire table C, all the numbers, 1 through 100, and you do them in order, and you must put next to each number all the possible combinations which make it up. A number only made up of itself times 1 should be underlined in red. So the number 1, you can only make the number 1 with 1 times 1. And 2, you can only make 2 with 1 times 2. And 3, you can only make 3 with 1 times 3. 4 is different, right? 4 has that 2 times 2 in there. So whenever you have that 1 times the number, and that's the only way, you underline this with a colored pencil in red. So 1's going to be underlined, 2's going to be underlined, 3's going to be underlined, but not 4, right? Because 4 is 1 times 4 and then 2 times 2. What about 5? Would you underline 5? The only way to get 5 is 1 times 5. So 5 would also be underlined. What about 6? No, I can do 1 times 6, but I could also do 2 times 3. 2 times 3 gives me 6. So 6 will not be underlined. Only the ones that have just a 1 for the factor. Those are the ones that you underline. So you're going to underline several of these, and there's a sheet 1 and a sheet 2, and you're going to fill up all the combinations. When this table has been completely filled, you're going to have a lot of underlined numbers, and these products, which have a multiplier of only 1, have a special name, and that special name is called a prime number. So all the ones that are underlined in red, whose factors are 1 and itself, those are called prime numbers. And that's a good thing to write down, the definition of what a prime number is. A prime number is a number whose only factors are 1 and itself. So 3 is a prime number, because the only way to get 3 by multiplying is 1 times 3. So 3 is an example of a prime number. So these are very important numbers, and you need to know all of them. All the way from 1 to 100, you need to be able to think about, out of all those numbers, which ones are prime. After you've completed this table, the calculation of the multiples, the first table and the second part, and you've gone all the way to 100, then you're going to make another copy of this table, the original table that we started out with, the multiples table, and instead of putting green dots and pink dots, this time what you're going to do is you're going to make circles. Okay, so listen to the instructions. You're going to start out with a blank sheet like this. It can be a 100 grid. It can be the sheet like this on Google Drive if you're in my class, or it can just be a 100 grid. Either one of those will work. And what you're going to do is you're going to think about the multiples or the products of the number 2. So don't circle 2 in green, and again, the colors are going to match up with the beads in the bead cabinet. So don't circle 2 in green, but circle all the products of 2, or all the multiples of 2 in green. So what would you circle first? You would circle 4 with a green circle, okay? You would circle 6 with a green circle. And then you're going to go to 3. Don't circle 3 with pink, but circle all the multiples of 3. So you would circle 6. That would be your first pink circle. Okay, and so on and so on. So you would circle all of those products with all of the different colors, matching the bead cabinet colors. And what you're going to end up with is all of the numbers that will not be circled are going to be your prime numbers. So the ones that have no circles around them, those will be your prime numbers. And that will be a good way for you to keep track of it, and a good way to know what a prime number is. And the last thing that I'm going to tell you before I say goodbye is that all of the other numbers, the numbers that are not prime, they have a special name too, and they are called composite numbers. So prime numbers are going to be all the numbers that do not have a circle around them. All the other numbers have a special name, and they are called composite numbers. All right, that's it for today. And as always, I thank you for watching. And this has been Peace Daddy. We'll see you next time.